Assalamu alaikum. So today our topic of focus is loci and construction. Again, a very important topic in Cambridge O-level mathematics. And we are going to see the different ways of construction. And more importantly, what we are going to focus on is actually why we are constructing it in a certain way, the concept behind it, on which I believe the focus is necessary. So let's look at the objectives. We will understand about the locus of a set of points that are at a given distance d from a given point O, that are at a given distance d from a given straight line, equidistant from two given points, equidistant from two given intersecting straight lines, and locus of a set of points that satisfy the above conditions using a compass, ruler, and protractor, and then a triangle given any three sides angle using a ruler, compass, and a protractor. So let's look at the first thing. So this is a locus or a loci. Basically, we are going to look at an example over here. So what is actually a locus or a loci? They're the set of points which satisfy a particular condition, right? So here we discussed all those four conditions that we are going to look at, right? So now basically, as you can see, there's a dog and it is on a let 2 meters long. Show where the dog is able to go. So what we are going to do through this question and the upcoming questions, we are understanding the first objective, that is at a given distance d from a given point O. That is what we are going to look at, right? So the locus of a set of points which are at a given distance d from a given point O. So what is this? Basically, there is a point O, which is a fixed point, and a specific distance, let's say 4 centimeter. We need to make a locus that all the time, if you are on that locus, you are 4 centimeter away from point O. Do you understand that? आप हमेशा 4 centimeter दूर हैं point O से. Point O is a fixed point, right? So we will be understanding this through the example of this dog, and this is the fixed point O, and this dog is basically attached to the this point through a string through a rope or a string with and that rope or string is basically 2 meters, right? Now it says that the dog is on a let 2 meters long. Show where the dog is able to go. So this is just 2 meters, right? So if we can say that the dog will go like this, and all the time it will be at a distance of 2 meters. From here also the distance will be 2. From here also the distance will be 2. From here also the distance will be 2. Right? All the time, the dog will be at a distance of 2. Now, this is basically a fixed point. This is your fixed point O. The fixed point. And this is your whole, the blue line, this whole circle is basically your locus. That anywhere in this circle, the dog can go. Because that is 2 centimeter, that is exactly the length of the rope, and it can go around 2 centimeter only, right? So that is the concept being given, and that is exactly a first locus at a given distance d from a given point. So your A is a fixed point, and that d is basically the radius, and that is the locus. Okay, so I will even be showing you this through the construction point of view, and let me do that. So as you can see that let's say our question says to make a locus of 6 centimeter from a given point O, right? Okay, So what do? We make that point O. Let's say this is the point O. We take a compass, we take a ruler, we measure the compass for 6 centimeter. We open it for 6 centimeter. We keep this part on and we will open it for 6 centimeter, right? I lock this. Basically, when you're actually doing it, you do not have the option to obviously lock it, but because you are holding it and you will hold it properly, right? Steadily. Okay. Let me draw the point again. Okay. And I lift it and I'll keep it to the point. Right? And then I'll draw the locus. It's a big one. It's not coming fully, but I can show it to you. So this is, and basically, if we measure this part to check, so this is the radius is 6, right? See, that's our radius, and that is 6. Right. And let's do some labeling. So 6 centimeter. All right. So that is the first thing which we understood. Let's look at the second part. So at a given distance D from a straight line. So that was a given distance from a point. We make a circle, a given distance D from a straight line. You make a line parallel to the given line, and that the distance, if you make parallel lines, so parallel lines at every point have between them have an equal distance. So that distance is the distance given to you, right? So let me explain this once more. At a given distance D from a straight line, from a given straight line, so that straight line is your fixed point. Let's say AB, that's fixed. And then this is the locus, or even this is the locus, right? So you will make it up and down, both, until and unless it is stated that you either need to make up or down, right? Otherwise, you need to make both of them. That is the correct locus, given line at a distance D centimeter from AB. So that distance is actually given to you, and then you need to make the locus, right? So that is how you actually do this. That is the concept behind it. And we will be looking at this in terms of how to make it. So let's look at that. All right. So let's say a line. AB is given to us. A, B, right? And let's say it says 4 centimeter, a locus 4 centimeter from AB, right? So the distance of that locus should be 4 centimeter from AB. So in that case, how do we actually do it? We will take our ruler and we'll take the compass. The distance has to be 4 centimeter, right? So the distance has to be 4 centimeter. Let's measure it. Let me open this lock. Let me keep it here and 4, right? So I get it at 4, I lock it. Let me keep the ruler. Okay, we keep it here. Okay, and now we are going to draw an arc. So that's one arc. You can draw arcs as big as you want, right? Let me draw another arc. let me draw the third arc. And then what do? You take the 3 points, 3 top part of the arc, and that's exactly where you need to make the line. If you see, all these 3 parts are the same, and this is where your line will be. And if I measure it through a ruler, I don't think so in this I'll be able to diagonally get the ruler vertically, but if I measure it, so this distance will be equal to 4 centimeter. And this is the same thing you'll do to make it down. You'll make arcs and then you're going to join. So this distance is equal to 4. Right? All right, now let's look at the next thing. We're done with the first 2 objectives. Now we will move towards equidistant from 2 given points, right? So you need to make a locus which has the same distance from 2 given points. And that 2 points are, in this case, A and B. Now, why in this case are we making a perpendicular bisector of line AB? Let me show it to you. So basically, if I take any point on this line and take it to AB, these 2 points are same, because this is a 90 degree and this is already into half and half. It is basically bisecting it as well. So let's say if I name this point O, so AO is equal to OB, so it will form an isosceles triangle at any point. At any point, I actually drag both of them, right? In this case, good that I made this mistake. Well, it happened because of the writing over here. It should be from one single point. So this point, they're all equidistant from AB. Why? Because this is a perpendicular bisector of this line. And the perpendicular bisector, if I make 2 lines, it actually changes it into an isosceles triangle. So that is something really important, right? That is something we are looking at. Okay, so and that is the reason why it is happening like that. And how do we actually do it? So let's come to the making of it. So let's say AB is a line of 6 centimeter, right? Let's make a line of 6 centimeter with pink color. Okay, so that's my AB. A, B. And then I need to make a perpendicular bisector. So it's very easy. You should open your compass more than 6. So if you remember from last time, it's opened at 4. So I can keep this only. That's not an issue, right? And you make an arc here. Again, you can make as big arcs as you want. And you make one arc at the bottom. Right? You make an arc here. Sorry, wait. Yeah, you make an arc here. And you make an arc at the bottom. Right? This is how you do it. And then you get this point. Right? And you get this point, right? Where it actually matches. And then you make a line. through those 2 points. And this is exactly a perpendicular bisector, right? So this is the perpendicular bisector. And how can we check that we've done it correct? So if we make a line from here to here and from here to here, in measurement, both of these lines need to be same, right? All right. Now we will look at the last thing, equidistant from 2 given intersecting lines. Now, these are the 2 fixed lines, this one, and a locus, a line, which is at any point on that line, it would be equidistant to both of the lines. So every line forms an angle. Every two lines in between them form an angle, right? And only way we can find an equidistance is by bisecting their angle into half. So we're actually getting the same distance from both the sides, right? So that's exactly what we are going to do. And how do we do that? That's very important. So in this case, it's an angle bisector. Okay, so hear me out. For example, I have 2 points. Now you don't need to do it with the protector. You need to do it with the arc. One way could be, you put the protector, you see, okay, it's 40 degree. I need to make a bisector on 20 then. But that's not how you do it. Let me make 2 lines. So let's say this is one of the line. And this is the other line, right? And you do not really need to measure any angle, but you shouldn't keep it very huge as well. You can keep it a little less, right? You need to you keep it on the tip where both the lines meet, and you make your first arc, right? This is the first step you do. You keep it on the tip, you make your first arc. Then you keep it where that arc is meeting with your line. You have 2 fixed lines. This is your first fixed line. This is your second fixed line. Where it meets your first fixed line, that is where you're going to keep it. And you're going to make another arc, right? So give me a second. But the catch is your compass measurement should not change. You should keep it the same, right? The opening of compass, how much you'd open it, which you kept over here, it should be the same, right? Okay. So you get your arc. And now you make a line and join this with the arc. This is exactly your angle bisector and the locus. The blue line is the locus. And how do you check it? You put your protector. You see that, okay, this is around like 34 degrees and 34 and a half. It's like 35K. Beach mein hai, and 34 should be like 17 and a half, right? So it's 15, 16, 17, 17 and a half. Yes. So that means you've done it correct. And please remember, you are doing your labeling as well, because that is also very important. Okay, now we will be looking at one question to actually explain you how the question is coming. and we are going to do the construction simultaneously. So construct and label triangle XYZ. Okay, first let me show you the learning objectives. We have covered the 4, and I've even simultaneously told you how to actually construct the loci. And we are on the last objective, which will also cover all of these and will be a revision for you. And we're even going to understand how to make a triangle. Okay. Construct and label triangle XYZ in which XY is equal to 10 centimeter, YZ is equal to 7.5, and angle XYZ is equal to 60 degree. Now understand, you have one of the measurements. You have 2 measurements of line and 1 angle. You have a measurement of line and you would always have it. So first you make one of those, any one you want. Sometimes you only have 1 measurement. So you will directly make that line. So first of all, we'll make a line of XY is equal to 10 centimeter. No use of protector, no use of compass. Up till now, first you only need to make a baseline of a triangle. So let's make a line of 10 centimeter. I hope it fits in the diagram. Okay. This is a line of 10 centimeter, and I name it X, Y. Right? That was the first step in constructing the triangle. Now it says that YZ is equal to 7.5. Now here you cannot make the next line with the ruler. Well, you can, but that's not acceptable. You need to use your compass for making the next line. So Y, it's with Y and then a Z point. So you'll be using a compass. And just by the way, even if you use a ruler, you can make a 7.5 line, but you do not know the angle. So unfortunately, you won't be able to make a right line. Your line actually can lie on multiple places. And through that arc, we will gauge all those multiple places, right? Your line can lie in. So basically, I forgot the measurement. I think it was 7.5. Yes. So we will first have to open it up for 7.5. So I keep it on 0. I open the lock and it's on 7.5. Yes. Close the lock. Right? And you make an arc. Right? That's quite a big one. Exactly. That's how you do it. Right? Then let's move. XYZ is equal to 60 degree. That means it is actually telling me the XYZ, this angle. Now, you know, I even know the angle. So of this part only, right? So I knew YZ and I know XYZ angle. You know, always the middle letter is actually the angle. So I know this angle. I need to take a protector. And now I know both the things and I can accordingly, you know, make. And I'll mark it at 60. So many people do even get confused in this part as well, that there are 2 parts of the protector: 0, 10, 20, 30, 40, 50, 60, 70, 80, and 187, 170, 60. Which one to follow? There is a 60 over here. There is a 60 over here. So there are 2 catches. One, you always need to see your baseline. Your baseline always starts at 0. So this baseline is starting at this 0. So you will follow the outer scale, not the inner scale. And the other part is you understand that 60 degrees is an acute angle, and this 60 gives an obtuse. So you would rather take this 60, right? This is how you take it. And we will make a line, right? And so where this line represents the openness of it, the angle, and the arc represents the length. So where the line and the length, they meet, that is exactly where the point is. And this is your point Z. And so let's join this. And so we get our triangle XYZ. Now let's look what the question is saying further. On your diagram, construct the locus of a point 6 centimeter from point Y. Okay, now that would be difficult because we have made Y at the bottom. So I will only make the upper part of it. 6 centimeter. Just let's take it to 6 centimeter. Right. Point Y, so point Y is your fixed point. A locus 6 centimeter from point Y. Right, this is it. So this is the part I can actually show over here. So how can you represent it? I'm even teaching you how you need to label your diagram over here. So you can represent this through, you can do this. And you can say that this is 6 centimeter, right? Equidistant from X and Z. So for equidistance, what do we used to do? We make a perpendicular bisector. So let's make it, you open it more than half. So I believe this is more than half. So one arc here, one arc at the bottom, then an arc from point X, one arc here, one arc at the top, right? And then we join the 2 points. This is the equidistant. We can, and by the way, we can and we should, if we need, extend the loci, the loci points, right? So this is what we get. And how can we represent this? We can find the measurement of XZ, we can write the measurements, or we can, even show it by saying that, okay, these are now equal, this is a 90 degree. And yes, we've made the locus. The point P inside the triangle XYZ is 6 centimeter from Y. That means there is a such point in this triangle, which is 6 centimeter from point Y, right? So that means this loci represents a 6 centimeter distance from Y. That means point P lies somewhere on that loci, but inside the triangle, right? Okay, that is the one thing. And equidistant from point X and Y. And also not only that, but it is also on this line which shows equidistant from point X and Z. So we can clearly see only one such point, and that is this. It's inside the triangle, it's equidistant from X and Z, and it's on the locus of a fixed distance of 6 centimeter from Y, right? And label clearly on your diagram the point P. So let's label it. We've just marked it, we haven't labeled. This is point P. And then the last part, I'm afraid I won't be able to do it. Measure and write down the length of PX. So for that, I need to tilt my scale, which is not possible. So, but still we can measure it away. We've just learned locus, haven't we? And we've just learned using protectors. So we can measure this point through the protector, and then we can keep the protector on the ruler. Isn't that the nicer idea? Measure and write down the length of px. Okay. So p and then x. So I need to close it a little. Yes, px. Right, so this is it. Oh, I didn't have to make an arc. Definitely not. Okay, I'll lock it and I'll check it. See, so this is around 4.678, 4.8 centimeter, right? So I can now say that px is 4.8 centimeter. Right, so we did this chapter in quite a detail. We saw all these things, we covered all these objectives, and I hope you learned something new or had a great revision. Obviously, practice as many questions as you can, and if you want any other videos, so please write down in the comment box. Thank you. Have a good day.